Welcome back. We had previously reviewed some basic concepts in motion. In this lesson, we will talk about the velocity time graph. We can track the motion of an object at certain time intervals along the path of its motion. We can also represent the motion of the object using the velocity time graph. Assuming we are given the data of the motion of a car as seen on this table, we can plot its velocity time graph with velocity on the vertical axis and time on the horizontal axis. Doing that will give us this graph. Let's use this graph to illustrate some important concepts. The first is uniform acceleration. Uniform acceleration describes the motion of an object whose velocity increases by equal amounts in equal intervals of time. If you look at the graph on the screen, you will notice that between point O and A, the velocity increases by 2 meters per second every 2 seconds. You should observe that it started at 0 meters per second, then climbed 2 meters per second 2 seconds later, then 4 meters per second 2 seconds later, and finally 6 meters per second 2 seconds later. This is what uniform acceleration looks like. It is a straight line with a positive slope on the velocity time graph. This slope is the value of the acceleration of the body in that time period. An example of a body undergoing uniform acceleration is a body in free fall under the influence of gravity, assuming there is no air resistance. Let's move on to the second part of the graph, the plateau. From A to B on your screen, you will notice that the velocity is neither increasing nor decreasing. That means it is just constant. We can say the body is undergoing uniform or constant velocity. We define this as the motion of an object where equal distances are covered in equal time intervals. This is the part of our velocity time graph that is a straight line parallel to the time axis. Here, the slope of the graph is 0, therefore the acceleration is 0 and the velocity does not change. We move on to the final part of our graph from B to C. This is the part where the velocity reduces by a constant amount with time. In this example, the velocity reduces by 2 meters per second every 2 seconds, and we call this uniform deceleration. This refers to a constant rate of decrease in the velocity of an object over time. For this example, we say the deceleration is 2 meters per second over 2 seconds, and that is equal to 1 meter per second squared. Note that the gradient of the velocity time graph during the deceleration is negative as it is sloping downwards. Therefore, we can say that during uniform acceleration, the velocity time graph slopes upward. During uniform velocity, it stays flat, and during uniform deceleration, it slopes